So this unit, it's unit 7. It's in section 9.1 in the book, or chapter 9 technically in the book. But everyone should have a gold sheet. Okay, again, hang on to it. Don't lose it. If you look at that gold sheet, the first 9 things on here, 1 through 9 on the gold sheet, you should kind of recognize, because we've already talked about the 6 reciprocal identities. We've already talked about the quotient identities. Quotient identities are just like tangent is sine over cosine, cotangent is cosine over sine. And then we did talk about the Pythagorean identity of sine squared plus cosine squared equals 1. Where that technically comes from is like if I have my unit circle here, okay, let's say that's my point here at pi over 4, we'll call it, okay. If I had my sine value is my y coordinate, right? So instead of writing pi over 4, let's write my coordinate here, because this is technically square root of 2 over 2, square root of 2 over 2, right? So if I take my y value, so this value, and I square it, and I take my cosine value, so this value, my x value, and I square that, I end up getting 1. That makes sense, right? Because our unit circle, the radius is always what? 1 all the way around. So it's just Pythagorean theorem in the unit circle. That's where the sine squared plus cosine squared equals 1 comes from, okay? Now, from that Pythagorean identity on your gold sheet, if you look to the right, there are 2 more columns that are very similar to this. How do I get those 2 other equations there for number 9? How do I get the sine squared x is equal to 1 minus cosine squared x? Subtract it, right? All I got to do is subtract sine of x squared. And then on my gold sheet, this is the second, actually it's the third thing in there, cosine squared of x is equal to 1 minus sine squared of x. Okay, so it's just manipulating the equation that you're given right here into something else, so that way we can use it when we're verifying or simplifying our stuff here in this section. Okay, so to get number 10 and number 11 on your gold sheet, what we can do is we can take, Miss Daughtry calls this the grandma identity, okay? The grandma identity, take the sine squared, cosine squared equals 1. If we divide it by cosine squared of x, we're going to end up getting this second function there, number 10 on the graphs, or on the gold sheet, sorry. So let's go ahead and do that. So I'm going to write, I've got sine squared of x plus cosine squared of x is equal to 1. And I'm going to divide all of this by cosine squared of x. Okay. Right away, what do we see? What's happening up there? One of those things goes away. Which one? Cosine, right? This becomes a 1, right? Now, if you look on your chart, what is sine over cosine equal? Tangent, right? So I could rewrite this piece right here. This is technically tangent squared x, right? This is a plus 1. And then if I have the reciprocal function of cosine, 1 over cosine squared of x would be the reciprocal of, or the reciprocal of cosine is secant. So this would be secant squared of x. Now, if you look on your gold sheet, this is the identity number 10, the Pythagorean identity number 10, and we got it by dividing cosine squared of x from our original. Again, if you look at row 10 on your sheet, the other 2 equations that are in here are found by just manipulating this equation. So subtracting the 1 over, or subtracting the tangent of squared of x over. It's just the same thing, slightly different. Okay? Make sense? Okay. Again, if we take that grandma identity and divide it by sine squared of x, this time we're going to get something a little different, but again, very similar. So sine squared, cosine squared equals 1. Let's divide by sine squared of x. Okay, which one's going to cancel out here? The sines. This becomes 1. So I've got 1 plus Now look at your gold sheet if you don't remember. What's cosine over sine? Cotangent. So this becomes cotangent squared of x. And then the reciprocal of sine, 1 divided by sine squared, would be cosecant. So cosecant squared of x. Just a quick little note, make sure when you're writing the squared that it's in between and it's not like cosecant x squared. It means something different. Unless you have the parentheses, these two things would not be the same. Okay, so make sure you write it one of these two ways. Either one is fine. Okay. Okay. So that's now going up through identity number 11 on your trig sheet. Okay, so today we're focusing on 1 through 11, using those trig identities to help us verify, simplify, and do all those things for the problems that we're going to have. Okay, so the unfortunate thing for this in math, a lot of us like math because there's rules you have to follow. You have to do it a certain way, right? To some extent, right, like solving equations and things, like we can do it multiple different ways, but we can get the same answer, right? That's the other nice thing about math, is that it's not only one correct way, but you all end up getting the same answer, right? That's the beauty of it. So with these next 7 steps here that Miss Daughtry came up with, they are all valid, but they are not like you have to do this every single time, right? Especially not the last one. Please don't cry every single time when you're trying to do this, right? So it might be helpful to change your stuff into sine and cosine, okay? If you're given stuff in terms of cotangent, tangents, cosecant, secants, change it in terms of sine and cosine. It might help you simplify it, okay? Might not always, but it might help. Next thing, if it shows addition, it might actually be good to do the addition. Same thing if it shows multiplication, it might be good to do the multiplication, okay? You might need to multiply by the conjugate. We'll do an example like that, multiplying by the conjugate. Anyone remember what the conjugate is? Like if I had a fraction, let's say it was like 1 over x minus 1. What's the conjugate of 1 over x minus 1? Or even this was like a 3x or something like that. The conjugate of x minus 1 is x. Just x plus 1. But yes, you're thinking your reciprocal. Yeah. So you'd multiply the top and the bottom by x plus 1, right? So that's the conjugate. Changing the denominator with a plus or a minus depending on which one you're given. You might have to factor, you might have to FOIL, but don't freak out because there's going to be trig functions in there. It's going to be like sine of x plus 1 squared. You might have to FOIL that, okay? And then again, don't cry, but keep trying, okay? Okay. All right. Again, the reason we are doing this to verify and simplify is 1, because math is beautiful and it's wonderful. 2 is because in calculus, you're going to be given certain trig functions in integrals or in derivatives that you might not be able to simplify or solve because there is no formula for it, but we can use these trig identities to actually help solve them. Does that make sense? Okay. So again, why it's important not to lose this sheet if you are planning to take calc next year, okay? All right, let's go ahead and try out some problems. First one here. Okay, it says we want to simplify this to a power of a single trig function. Okay, single trig function, sine, cosine, tangent, cotangent, secant, cosecant. One of those 6, but we're going to simplify it to a power of one of those. So if you look on your sheet, where do we see 1 plus tangent squared of x? 10. Number 10 on your gold sheet. This can change into what? Secant squared. Secant squared. So 1 divided by secant squared of x. That's using number 10 on your gold sheet. So, could I rewrite 1 over secant squared of x? What's the reciprocal? Cosecant, right? So cosecant, oh no, what am I saying? It is cosine. My bad. Cosine, yes, cosine squared of x, right? It's the reciprocal function of secant is cosine squared. So these two things are the exact same. We were just simplifying it into just one trig function, okay? Does that make sense? Okay, the next one's asking us to simplify to a product of 2 trig functions. So I want to simplify tangent of x plus cotangent of x into a trig function times a trig function. Okay, so one of the steps on the 7 were if we can do the addition, let's do the addition. But can I just add these things together right now? No. So let's rewrite them, because another one of those one of those hints were to rewrite them in terms of sine and cosine. So how could I rewrite tangent in terms of sine and cosine? Sine over cosine, right? So this is sine of x over cosine of x. How do I write cotangent of x? Cosine over sine. Okay. Now, can I add these across yet? No, if I want to add them across, what do I have to have? Common denominators. So for the first one, I need to multiply this function, or this fraction, by what? Sine of x, because it's the denominator of my other fraction. And then I need to multiply this fraction by cosine of x. Okay, so if I perform that multiplication, I'm going to end up getting sine squared of x, same thing as sine of x times sine of x. Be okay with that? And then I've got cosine of x times cosine of x. That's just cosine squared of x. And then what's my denominator going to be here? Sine x cosine x. No addition sign down there, right? Only on the top. Okay, so this is not quite a product of two trig functions yet, right? So let's keep going. I've got two squared trig functions. So let's look at our Pythagorean identities. Is there something about sine squared, cosine squared? Yeah, what does it equal? 1. So we're going to rewrite this. This is now equal to 1 divided by sine of x cosine of x. We're really close because this is like the reciprocal of two products multiplied together, right? So if I want to multiply two trig functions together, couldn't I rewrite this as 1 over sine and 1 over cosine? Same thing, right? Which means 1 over sine is equal to cosecant. And 1 over cosine is equal to secant. So cosecant of x times secant of x is equal to tangent of x, cotangent of x. Pretty crazy. Wild stuff. We're going to try some verification, okay? So for verification, we're gonna be given an equation, and you're going to choose one side of the equation and make sure that it equals the other side. Okay, we're not going to work on both sides. We're not going to solve it like an equation. We are going to just mess with one side of the equation and make it equal the other side. Okay? Again, more than one way that you can do this. I was helping someone earlier with this on their homework, and they did it a different way, but they got the same answer. Okay? So your algebra could look different because maybe you saw a trick that maybe I didn't see, or vice versa. Okay? So again, usually you're going to choose the more complicated looking side. So for this first example, number 3, we're going to choose the right-hand side, and we're going to make that look like the left-hand side. Okay? So what does your gut tell you we should do first on the right-hand side? Distribute. Let's do it. Okay, so this is cosecant of x times cosine of x plus cosecant of x times sine of x. Okay, another helpful thing, we've got things in terms of cosine and sine partially, but let's change cosecant into terms of sine and cosine. So what is cosecant in terms of sine and cosine? 1 over sine. So let's rewrite this as 1 over sine of x times cosine of x, and 1 over sine of x times sine of x. So what happens with those sine of x's? They cancel out, and we're left with 1, right? If I rewrite this first fraction, cosine of x over sine of x plus 1. We're really close. We want to get cotangent. So what does cosine over sine equal? Cotangent, right? So this is equal to cotangent of x plus 1. We did, in fact, get our original equation there. So that's all the verifying that it needs. All right, let's look at example 4. Okay, we're going to verify this fraction on the left side is equal to those two things squared on the right side. So which one do you think we should work with here? The left side. Let's work with the left-hand side here. Okay? Again, there's kind of more than one way that you could do this. What do you guys think we should do with the left-hand side there? Let's put everything into sine and cosine. So tangent of x, I could rewrite that as sine of x over cosine of x. And then cotangent of x would be cosine of x over sine of x, right? And that's all being divided by sine of x, cosine of x. Okay. Could we maybe split this into two fractions? So like have this fraction and then subtract this fraction? That's how my brain kind of thinks about it, because otherwise we're going to have to make common denominators here on top in order to combine those. So let's split them. If I split this into sine x over cosine of x, but then I'm dividing by sine x cosine of x, isn't that the same thing as multiplying by 1 over sine of x cosine of x, right? So this is that blue piece that I highlighted. And then if I split up the yellow side, I'm subtracting cosine x over sine of x, and I'm multiplying that by the reciprocal 1 over sine of x cosine of x. So I look at that multiplication in between that subtraction there. On the left-hand side, the blue side over there, what am I going to be able to get rid of? Sine of x. That goes away. And I'm just left with 1 over cosine squared of x. What about the yellow side over there? What can I get rid of? Cosine of x. So I've got minus 1 over sine squared of x. We're really close. We've got a subtraction sign now. How am I going to get to secant squared, cosecant squared? They're flipped, right? That's a reciprocal. So the reciprocal of cosine is going to be secant. So secant squared of x minus cosecant squared of x. So we did, in fact, verify that these two things are equal to each other.
What happens if they're not equal to each other?
Okay, last example here. We are doing one that's going to require us to use the conjugate. Okay? Which side would I be able to use the conjugate on? The left, which means we're going to manipulate the left-hand side to make it look like the right-hand side. Okay? So conjugate of 1 minus sine x is 1 plus sine x. Okay, so I'm going to rewrite this as cosine of x times 1 plus sine of x. And then I'm going to let you guys try dividing, or not dividing, but try foiling out that bottom part there and make sure that we get the same thing here. I'm going to give you guys about 45 seconds to a minute to try it out. Because if we distribute, we get 1 plus sine of x minus sine of x, and then minus sine squared of x. But those two things there in the middle, will go ahead and cancel out. That's the nice part about the conjugate, is it leaves us with just the 1 and the squared function, which if you look at your trig identity form, what is 1 minus sine squared of x? Bless you. Cosine squared, right? So now I could rewrite this. This is the same thing as cosine of x on the top times 1 plus sine of x, all divided by cosine squared of x. Now, do I even really, excuse me, do I even need to distribute this cosine? No. Can't I just cross it out?
Yeah.
Get rid of this one? But then how many am I going to have on the bottom?
1.
Just 1. So get rid of that 2. So now I have 1 plus sine of x divided by cosine of x, which is what we were trying to verify. Now, if the trig function is not squared, your Pythagorean identities don't work. So 1 plus sine is not going to be anything, okay? Let's see. So that is it for the notes piece. There are about 20 questions, okay, on your homework, but you have almost like 45, 50 minutes right now to work on it. So I'm hoping that a lot of us can get most of it done in class. But you can't fake it, right? We gotta try it out first. The instructions on the first part are gonna say to simplify. It's going to say simplify it, change things into sine and cosine, and your final answer might not be sine and cosine. It might be tangent, it might be cotangent, something like that. But you're gonna wanna change it into terms of sine and cosine in order to simplify it, okay? The second part of your homework is verifying. Verifying is what we just ended with here. Pick one side of the equation and make it look like the other side, okay? The answer key might look different than how you got to the answer, but if you got to the same answer for verifying, that's totally fine. As long as your way logically makes sense with what you used. Does that make sense? Cool. Okay.